Welcome back. In this tutorial, we'll learn how to inspect and troubleshoot Docker containers using real debugging commands. We'll explore Docker Logs, Docker Logs-F, Docker PS-A, and Docker Inspect to identify container issues directly from the terminal. Let's get started. First, let's check the running containers. Here we can see the PostgreSQL container from the previous tutorial. Let's stop the PostgreSQL container to clean the environment before starting the debugging examples. This keeps the environment clean before starting our debugging examples. Here we remove the stop container from the system. Now let's simulate a failed container. We are trying to run an Nginx container with an invalid command. This gives us a real example for troubleshooting and debugging Docker containers. Notice the difference between Docker PS and Docker PS-A. The regular Docker PS command only shows running containers, but Docker PS-A also displays stopped and failed containers, which is very useful during troubleshooting. The Docker Logs command allows us to inspect the output generated by the container. Here we can clearly identify the exact error message explaining why the container failed to start. And here we can clearly identify the problem. The container failed because Docker tried to execute a command called invalid command, but that command does not exist inside the container. This is exactly why Docker logs are so important during troubleshooting. Logs help us quickly understand why containers fail and what happened during the startup process. Instead of using a simple failed container example, let's simulate a more realistic troubleshooting scenario. In this example, we'll create a Node.js application container trying to connect to a PostgreSQL database container using Docker Compose. We'll intentionally configure the wrong database password so the application fails to connect. Then we'll use Docker Logs and Debugging commands to identify the problem, fix the configuration, and verify the application working correctly again. For this example, we'll build a small multi-container application to simulate a real troubleshooting scenario. Here we are creating the files required for the application, Docker image, and Docker Compose configuration. Docker Compose automatically creates the network, starts the PostgreSQL database container, and then starts the Node.js application container. Inside the application configuration, we are intentionally using the wrong database password. This will cause the Node.js application to fail when trying to connect to PostgreSQL. Next, we define the package.json file for the application. Then we create the Docker file for the Node.js application. This Docker file defines how Docker builds the application image, installs the dependencies, copies the application files, and starts the Node.js server inside the container. At this point, everything is ready. The application container, the PostgreSQL database container, and the Docker Compose configuration are already configured. So now we can start the complete environment using Docker Compose up. After starting the environment, we can verify the container status using Docker PS. Here we can see both containers running as part of the Docker Compose application stack. Next, we use Docker Logs to inspect the application container output. And here, we can clearly identify the problem. The Node.js application failed to authenticate against PostgreSQL because the database password is incorrect. This is a very common real-world troubleshooting scenario when working with backend applications and containers. At this point, we already identified the root cause of the problem using Docker Logs. The application was using the wrong PostgreSQL password. So let's go back to the app.js file and replace the incorrect password with the correct one. After updating the application configuration, we need to rebuild and restart the Docker Compose environment so the container uses the updated application code. Docker is rebuilding the Node.js application image using the updated configuration. Depending on the internet connection and the dependencies, this process may take a few moments. Once the rebuild is completed, we'll inspect the container logs again to verify the application connecting successfully to PostgreSQL. The application container is now running successfully. So let's open the application in the browser and verify everything working correctly after fixing the PostgreSQL connection issue. Finally, let's use Docker Inspect to explore additional container information. Docker Inspect provides detailed metadata such as networking configuration, environment variables, ports, container state, and many other runtime details. This command is extremely useful during real troubleshooting and debugging scenarios. We can also open Docker Desktop to visualize the application stack graphically. Here we can inspect the running containers, logs, ports, and Docker resources directly from the interface. Before finishing, let's summarize the troubleshooting workflow we used in this example. The Node.js application container communicates internally with the PostgreSQL database container through Docker Compose networking. Initially, the application failed because the database password was incorrect. Using Docker logs, we identified the authentication error, fixed the application configuration, rebuilt the container, and verified the application working correctly again. And that's it for this tutorial. Today, we learned how to troubleshoot Docker containers using Docker Logs, Docker Inspect, Docker Compose, and real backend troubleshooting scenarios. We also explored how to identify application errors, inspect logs, rebuild containers, and debug PostgreSQL connectivity issues inside a multi-container environment. Thanks for watching, and see you in the next video.